Welcome to the Deep Dive. We know you're here because you want the key insights without drowning in a sea of data. That's exactly what we do. And today, we're going deep, really deep, into the Emirates Water and Electricity Company's 2020 Statistical Report.
Yeah, this is like your fast track to understanding the world of water and electricity in the UAE.
It really is.
EWC, they took the reins from ADWEC back in 2018.
Right.
And they've got this huge task, right? Keeping everything running, the lights on, the water flowing.
Essential stuff.
Absolutely essential across Abu Dhabi, Al Ain, Al Dhafra. It's about finding that balance, the sweet spot between what we need and what they can actually supply. They've got these long-term strategies, big plans. And the great thing...
They actually share all the details with us.
They do in this annual statistical report.
And that's exactly what we're focusing on for this deep dive. For you.
Just for you.
We're going to pull out the most fascinating, the most interesting, most important bits about electricity demand and production.
Yeah, from that 2020 report.
We're not just throwing numbers around here. We're going to actually unpack what they mean, really break it down.
Yeah, paint the picture.
Paint the picture, exactly. Okay, let's jump right in. First up, electricity demand. The report gives us this long view from 1999 to 2020, looking at the highest and the lowest points of demand in Abu Dhabi.
What really hits you first is just this consistent climb.
Yeah.
They say in the report, the average yearly increase in the highest demand globally was about 6.5%. But in Abu Dhabi, for the system, the highest demand, it jumped by an average of 8.9% each year.
Wow.
And even at the lowest point of demand each year, there's still this significant growth, a 7.7% average increase between 2005 and 2020.
So it's growing, it's growing, it's growing.
It's growing.
What does that tell us?
It tells you this region needs power, and it needs more of it every year.
It's hungry for power.
It is.
Okay,
Yeah.
so it's not just about the overall growth. It's also about, how the lowest and the highest points of demand in a year relate to each other.
Yeah, this ratio, it's always changing year to year.
So what's the story there?
Well, imagine a water park.
Okay, I like water parks.
Huge crowds on the weekends, but then during the week, it's pretty much a ghost town.
Yeah, not using all that capacity.
Exactly, not efficient. And it's similar with electricity.
Right?
If the lowest demand is a tiny fraction of the highest, it could mean that some power plants are just sitting there, idle.
Not doing much.
But if the minimum demand is close to the peak,
Then what?
it means things are more stable, more consistent. We're using the power supply more evenly. The variations we see, they reflect everything. The seasons changing, the pace of businesses, how fast things are developing.
All of that. Okay, let's get a bit more focused now. The report has this graph showing the system's weekly electricity demand peaks from 2011 to 2020. Can you almost see it, like how our need for energy goes up and down, like the rhythm of the week?
Oh, absolutely. It's like a visual timeline, how demand fluctuates throughout the year. Those recurring peaks probably linked to when it's super hot and everyone's blasting the AC.
Makes sense.
But the shape of the curve for each year, it's similar, but the highest points, they keep getting higher.
There's that growth again.
That growth, yeah.
Now, the report dives into something called the 2020 System Load Duration Curves. Sounds technical, right?
It does.
But it's actually a pretty clever way to understand how often we're pushing the limits of our electricity supply.
Think of it like a traffic report, but for the power grid.
Oh, okay.
It shows you what percentage of the time in 2020 the demand for electricity hit or went above certain levels. A steep curve, that tells you there are big swings in demand. But if it's flatter, it means a more steady need for power. What's interesting is that water demand would probably have a totally different curve.
Oh, why is that?
Because we use water differently than electricity, right? Different patterns, different needs.
Okay, that makes sense. So let's narrow our focus to the Abu Dhabi system electricity demand in 2020. The report gives us this snapshot comparing the average demand in January, usually the lowest month, to July, the highest. And then we see the demand on the single day with the absolute highest demand, that was July 20th, and the absolute lowest, January 31st. What's the big takeaway when you compare those profiles?
The difference between January and July is just huge.
Yeah.
The average demand in July, way higher across all hours of the day. Summer heat.
Summer heat, yeah.
When you look at that peak demand day in July, you can probably see those peaks in the afternoon and evening when the temperature is at its highest. Then you flip to that minimum demand day in January, and it's much flatter, much lower demand throughout the whole day.
Makes sense. Okay, let's zoom out a bit and look at the different regions. Abu Dhabi, Al Ain, and Al Dhafra. The report gives us the peak annual demand, in megawatts for each of those regions, and then the total system peak, all from 1999 to 2020. In 2020, that overall system peak hit 11,757 megawatts. Anything stand out to you? Any interesting year-over-year changes or differences between the regions?
Yeah, I think the fact that the peak demand is consistently going up across all three regions, that's something to note. And the Abu Dhabi region, they just consistently have the highest peak demand. Another thing to keep an eye on is Al Dhafra.
Okay, what about Al Dhafra?
Any big increases in their peak demand in recent years, that could mean more industrial activity, more infrastructure development.
Right. And what about the other end of the spectrum? The lowest point, the minimum annual demand, same region, same time frame. The system-wide minimum in 2020 was 5,301 megawatts. The report points out that's about 45.1% of that peak we just talked about.
Yeah, that 45.1% figure, it's a good reminder how much our energy use changes. Keeping an eye on how those minimums relate to the peaks year after year, they give you valuable insights. You see how our demand patterns are changing overall, how efficient we're being with energy.
Right. Now, the report gets really specific. It tells us the exact dates when those peaks and minimums happened in 2020 for each region and for the whole system. The system hit its peak on July 20th.
Right in the summer.
Right in the summer. Lowest point, January 31st.
Makes sense.
Abu Dhabi and Al Ghurair, their highest demand was a little later, August 18th. Al Dhafra matched the system peak on July 20th. When we look at the minimums, there's a bit more variation. What do you think? Any patterns there?
Well, the system-wide peak lining up with Al Dhafra's peak and both happening smack dab in the middle of summer, that really tells you how much those high temperatures drive our need for electricity. It's all about cooling. And those minimum demands, they generally happen in January and February across the board, the cooler months.
Right. Okay, let's break it down by month. We have the higher and lowest demand figures for each month from 2016 to 2020 for each region and the entire system. Unsurprisingly, 2020's highest demand month was August for the system, lowest was January. If you look at the individual regions, do we see those same monthly patterns?
Generally, yes. The months with the highest demand, they tend to be during the summer in all the regions, though the hottest month might shift a little bit depending on where you are. And the same goes for the lowest demand months. They usually fall during the cooler parts of the year.
Okay.
And looking at these monthly figures, it gives us a much more detailed understanding of how demand changes with the seasons in each area.
Last thing on demand. The report gives us the ratio of the highest demand in a month to the total annual peak demand. This is for each region and for the system, all for 2020. In Abu Dhabi, August hit 100% of that yearly peak demand, while January's peak demand was only 52.11% of that annual high. That's a massive difference.
Huge. It shows you how much Abu Dhabi's need for electricity changes with the seasons. January's peak, it's barely half of August's. That just screams how much climate plays a role in how much energy we use.
It really does.
And the report, it gives you those same ratios for Al Ain and Al Dhafra too. So you can compare how those seasonal demand shifts play out in each region.
Right. All right, let's shift gears now. Let's talk about electricity consumption and how it's generated. The report gives us the total yearly energy demand in gigawatt hours from 1999 to 2020 for Abu Dhabi, Al Ain, Al Dhafra, the whole system, and they even give us this global figure that includes electricity that's sent to the Northern Emirates. What do we see overall?
More growth. 2020, the total system demand, it was a whopping 63,868 gigawatt hours.
That's a lot of energy.
It is. And keeping track of that yearly increase, that's crucial for long-term planning. Building the energy infrastructure we need, making sure we can keep up with these growing needs. And that global figure, including those exports, it really shows you how big a role EWEC plays in the UAE's energy network.
Absolutely. Okay, so we also get a breakdown of the monthly energy demand from 2016 to 2020. This shows how that total yearly consumption breaks down throughout the year. I'm guessing those summer months account for a big chunk of that total.
You guessed it. It mirrors those peak demand figures. The monthly energy demand data will clearly show a spike in the summer months. Higher energy use overall, driven by cooling needs and life in the summer.
Life in the summer.
Right.
Now, the report also gives us the ratio of the monthly energy demand to the annual peak energy demand. Again, for Abu Dhabi and Al Ain in 2020.
Right.
Abu Dhabi, August, again, hits that 100% mark. January sits at 58.51%. Al Ain, August at 98.54%. January, much lower, 41.53%. These percentages really show us how our total energy use connects to the year's highest demand point.
They're incredibly helpful for understanding not just when that absolute peak demand hits, but also how our total energy consumption shifts throughout the year in relation to that peak. That lower January figure for Al Ain compared to Abu Dhabi, it's interesting. It might mean there are different patterns of energy use there, maybe a bigger proportion of residential demand compared to commercial or industrial.
Okay. Let's talk about where all this electricity comes from. Generation. The report tells us the total annual electricity generated by region for 2020. Abu Dhabi generated 38,148 gigawatt hours. Al Ain, 11,508 gigawatt hours. Al Dhafra, 14,212 gigawatt hours. This gives us some insight into which areas are the big power producers.
It's that geographic breakdown. It's crucial for understanding where the power generation capabilities are within the EWEC system, which areas are really contributing the most to the overall electricity supply.
We also get a breakdown of the annual electricity generated by company for 2020. Some of the big names: Taweelah B at 16,133 gigawatt hours, the Taweelah B2 extension at 2,219 gigawatt hours, the Taweelah new extension producing 7,659 gigawatt hours, and the Shuihat open cycle gas turbine, OCGT plant, with 10,069 gigawatt hours. That helps us understand the key power sources within the system.
Yeah, it gives you a peek into the individual power plants. What are they contributing? What technologies are they using to generate electricity? It helps assess the output, the performance of these individual assets within EWC's whole generation portfolio.
And finally, while we can't see the exact numbers in the excerpt we have, the report tells us the total energy generated by the type of generator, and the percentage each type contributes to the total for 2020. This would show us things like gas turbines, solar power, maybe even nuclear energy. Gives us a clearer picture of the energy mix.
It's all about diversity and sustainability. Those percentages would highlight how important different fuel sources are, what progress is being made towards renewable energy goals.
Right. So as we wrap up this deep dive into EWT's 2020 statistical report, a few key things jump out. EWBC, vital organization.
Absolutely.
Abu Dhabi's energy security depends on them. And we see that electricity demand, it's just going up and up with those clear summer peaks. And then you've got those interesting regional differences in how much electricity each area needs and where it's coming from.
It's true. This data, it shows us how much climate affects energy demand. It gives us a really detailed picture of the electricity landscape in 2020 across Abu Dhabi, Al Ain, and Al Dhafra.
Right.
And it highlights this ongoing need. We need strong infrastructure, careful planning if we're going to keep meeting these growing energy demands.
We've got to stay ahead of the curve.
Okay.
Here's a final thought for you to ponder. We've been looking back at 2020.
Right.
But looking ahead, what future challenges, what future possibilities do you see for EW and for the UAE as they try to make sure we have a sustainable, reliable energy supply? What questions does this data spark for you about the region's energy future?
Big question.
Huge question.
We've got population growth.
Right.
The economy is changing, diversifying, and then there's this global push for cleaner energy. All of that is going to shape how much energy we need and where we get it from. This 2020 report, it's a really valuable benchmark. It helps us understand how those future trends might unfold.
Absolutely. So if you're like us and you find this stuff fascinating, go check out the full report, the 2020 Statistical Report.pdf on the EWEC website. It's a treasure trove of data. Thanks for joining us for this deep dive.